Hello guys, hope you're doing great. Today we're gonna be building an IP controlled robot that will be controlled over a UDP communication. So this is my hardware. I've just finished assembling it today. All of these components are fixed with the help of double tape. Three of the ultrasonic sensors are used for collision avoidance, and one edge bridge over here inside that will be controlling the motors, and this is a separate battery power given to the edge bridge. It's giving 12 volts to the edge bridge. Actually, the edge bridge pins that will be controlling the motors is connected to the Raspberry Pi's GPIOs, and for the Raspberry Pi I have placed a separate power bank over here, and this will be used to power up the Raspberry Pi. So this is the separate Wi-Fi receiver that will be receiving the signals, and I have also connected one GPS that will not be using it right now, but I'll be using that later on for further cool stuffs. And this one as well over here, compass module HMC 5883. We'll be using these compass and GPS for the future part of this robot. So but currently we'll only be controlling this robot over a UDP communication with the help of our keyboard. Let's dive into the software part of the project. I'm using Qt for my GUI, and the reason for that was I was trying to find some functions in Python that can actually capture the key press and key release events. So there were a lot of options like Pygame and a few of the other libraries that were giving me these options, but the most easiest one that I've came across was Qt. So Qt provides some of the features of key press and key release events. So these are the key press event, and this is the key release event. Okay, so first of all, you just need to create a simple GUI in Qt. So for that, let's open the Qt, and this is the GUI that I've created. I'm not actually using these buttons right now because I'm controlling my robot with the keys. But just for the sake of implementation, I just did that. So okay, so once you're done with the GUI, just save the file as blah blah.ui. So I've done main.ui, and go into the directory where your main.ui is saved. Then over there, just you need to convert this Qt GUI into Python code. There's a library called PyQt that actually does that for you. So what you need to do is just type in PyUIC4, and over here just write the name of your UI file. For example, we have main.ui. And over here you need to write the output Python file, that what name you need to give to the Python file that will be generated. So I have already done that and given a name of main.py. So when you press enter, this file will be automatically generated, main.py. So I've done that, so I won't do it again. So in this main.py file will be your actually the GUI which you have created. I have imported this main file, and inside that file my class name is UI main window. So now I'm starting the application like this .qt application, and this line will actually execute my GUI that actually pop-ups. So let's actually dive into the UDP part. So first off, I'm creating a socket object. This is the default family type for the UDP communication, AFINET and socket.datagram. These two functions I am actually using for my key press and key release events. I have created a small dictionary over here with named verbose. So I have two keys, one is FP and LR. So FP will be storing the value of forward and backwards, and LR will be for left or right. So I'll be updating these values corresponding to which key is currently pressed. In this event variable, the actual key that is being pressed will be there. So over here I'm checking that whether the W key is pressed. W is for forward. Then update the key FP in the dictionary with F. And similarly, if S key is pressed, update the key FP with the B backwards. And similarly for left and right. And then finally I'm just converting this dictionary into JSON format. JSON data equals JSON.dumps verbose. So this actually takes the dictionary and converts it into a JSON, and then finally sending it to the socket. Send to, this is the data, this is the actual IP address of the Raspberry Pi, and I'm sending at 8001 port. And just the same thing for key release events. For any key that is being released, I'm going to update an S inside this FP and LR keys. S is for stop. So as soon as you release the key, and signal of S will be sent to the Raspberry Pi, that will indicate that you need to stop now. Converting it to JSON and just simply sending it over the UDP communication. Simple as that. So let's have a look in the code that is actually receiving the UDP signals from the PC and actually controlling the motors. So that code is inside the Raspberry Pi. So let's first dive into the Raspberry Pi. For that, open the PuTTY, write in the IP address of the Raspberry Pi. I assume that you know how to figure out what's the IP address of your Raspberry Pi. But for those who don't know, let me show you a quick tutorial on that. In your browser, just type in the IP address of your router and go into the device info. So I'm using my PTCell router, and your router will be of different vendor, so the main window of your router will be different from mine. So go into the DHCP table, and over here I'm looking at all of the devices that are connected with my router. You can have a look at this, that my Raspberry Pi is actually connected to 192.168.1.8. Let's write this IP address in the PuTTY, and so we need to actually share the screen. So let's enable X11 as well. For those who need to know how to share the screen, there are a lot of videos on the YouTube. Just have a look on that. Okay, open. Write in the username and password. Start LXDE. It will take like a bit long. So this is my code, motor.py. So first off, I need to import socket, definitely. I need to import JSON and obviously the library to control the GPIOs of the Raspberry Pi. So I'm actually giving the PWM signals to the motors so that to control it in a limited way. Defining the GPIOs for all of the motors. So two speeds are being used for PWM. One is slow speed and fast speed. So that we're actually going to be using it for example, if you want to move left, the motor on your left will be actually moving in the fast speed, and the motor on your right will be moving in the opposite direction but in the slower speed. So setting the GPIOs as an output. So 4 of the functions that I've defined: reverse, forwards, turn left, turn right. Let's have a look at the reverse. So first, P and Q are the right motor, and A and B are the left motors. So I'm moving both of the motors in the reverse direction, and over here in the forward direction, we're both with fast speeds. And for turn left, the left motor is on the fast speed and the right motor is on the slow speed in the reverse direction. And similarly for turn right function, I'm giving fast speed to the right motor and the slow speed to the left motor in an opposite direction. And I've got a function for stop all, and that's it. So same socket definitions goes over here as well as creating a socket object and with default UDP communication. So now we need to actually listen to our IP address. So for that we need to bind our IP address to some specific port. From my PC, I'm sending the signals over a port of 8001. So for that I need to bind my IP address to 8001 port. So a simple while loop. In this we are actually receiving the signals. This is the data that will be storing the signals that are being sent from the PC. The signals that are sent are in the format of a dictionary, so we'll be getting those signals in a string format. First off, we need to convert those strings into a JSON format. So for that, we use loads. What we need to load is actually the data that is being received. So now we can actually access the keys and the values of the dictionary items. So I'm getting this is the name of my key, and this is also the name of my key. So whatsoever is written inside the FP will be stored in FP, and similarly for LR. From here I have defined 4 ifs: forward, backward, left and right, corresponding to which each function is being called. Back, forwards, reverse, turn left and turn right, and if stop comes, then stop all. Simple as that. So that's how I'm actually controlling my robot. Okay, it's time to move the robot. So I have just powered the Raspberry Pi from the power bank. So once you got the Raspberry Pi's IP, let's type that IP in the putty. My IP is 192.168.1.8. Open, type in the login username and password. Okay, so code that I've written is placed in desktop. It's with sudo python motor.py. Okay, these are some warnings for the GPIOs, just ignore them. So let's start the code from my PC. Okay, so let's press some keys to check whether the robot moves or not. Okay, oops, it's not happening. There's something wrong. Oh, okay, I haven't powered on the edge bridge, so this is the okay, let's turn on the edge bridge. Okay, so just turned on the edge bridge, so now it should definitely move. So that's actually happening. Great. Okay, perfect. Best practice is to just keep it on the floor like this.